In this lesson, we're going to learn our factoring for the difference of squares. So before we dive into the actual factoring process, let's review this type of foiling where we have two binomials, both have the same f term. The last term are the same values, but one's a positive, one's a negative. So what happens when we FOIL this out? What always happens in these cases is your outer and your inner end up being the same exact value, but a positive and a negative version. So when you add those up, you get 0x in the middle, which we don't really show the 0x. We end up with the first term and the last term, and the middle term has canceled out. So these are called square values. X squared from x times x, -9 from a +3 times a -3. So x squared is a squared value, 9 is a square value for 3. And again, in these cases, what's happened is your outer and your inner add up to 0. So we're going to reverse these. Here are a couple other examples of difference of squares. You've got x squared again. For x squared, you've got 4. That comes from 2 squared. You've got, again, a 4x squared. That come from 2x times 2x. You've got 25. That comes from 5 times 5. Another example, 4x squared is where you get 16x squared, and then 81 is the square of 9. So these are all examples of foiling resulting in a difference of squares. And of course, the word difference here is referring to the fact that we're subtracting these two squared values. Please add this to your notes. This is in general my two-step process for factoring these. So the first step, of course, involves you recognizing that you've got a binomial with a subtraction, and each value is a squared value for something. So the very first step would be to really set up your reverse FOIL parentheses. That's what I like to do. And then in the first step, and the step after that, recognize what is making your a squared. Okay, what's the root of a squared? Find the root, put it into your parentheses. Find the root of the second value, put it into your parentheses. And of course, the plus and minus could technically be set up right from the start, and it really doesn't matter which order you put the plus and the minus. It's got to be opposite signs, one and the other. Here's a pretty simple example. We recognize this to be a difference of squares where x squared is from x times x and 4 is from 2 times 2 with the subtraction in between. We can set up our binomial parentheses, plus, minus, factor the f term, x times x, factor the last term, 2 and 2. Example 2. Again, we have two terms, subtraction. I recognize the x squared. I recognize 4 is from 2 times 2. So this entire value here is from 2x times 2x. And this term is from 5 times 5. So you set up your binomial groups, your reverse FOIL parentheses, and put a factor for f in each f or first spots. Put a factor for each last spot. Putting this together with a GCF, you must always still pause at the beginning of the entire problem and factor out any greatest common factor if there is one first. So in this example, 18 and 8 have a greatest common factor of 2. That gets factored out right as the first step. And then you can pause and recognize, oh, we've got two terms with a subtraction. Are they squared values? So it may take a minute to figure this out here, but 9x squared is 3x times 3x. 4 is, of course, 2 times 2. So then we can reverse FOIL because these are squared values, plus and minus. Factor each of the first terms in each, last terms, and then don't forget to plant your GCF there again at the end of problem so that we have our three factors for this binomial expression here.